You ever look at a graph and just your eyes glaze over? It's just a bunch of lines and dots, right? Well, what if I told you they're actually stories, little narratives hidden in the data? And today, we're going to learn how to read them. By the end of this, you'll be a pro. All right, let's just jump right in with a fun little mystery. Think of us as data detectives. You're about to see the ratings for 3 different TV shows, and your mission is to match the story to the right graph. We've got a breakout hit, a fading star, and a show that had a crazy one-hit wonder guest appearance. Which is which?
Okay, here's our evidence. First up, show A. Just take a quick look. See that trend?
Now, here's show B. Whoa, totally different story, right?
And finally, our third clue, show C. Look at that weird spike. So keep these 3 images in your head. By the time we're done here, you are going to know exactly which is which. You'll have this case totally cracked.
But hey, before we solve the big mystery, every good detective needs a toolkit, right? So let's warm up. We're going to start with a simpler case to get our graph reading skills nice and sharp.
So check this out. This isn't just a graph. It's a 110-year story of 2 big American cities. We've got Baltimore in blue, we'll call it B, and Cleveland in red, that's C. You can literally see their histories playing out. They grow, they hit their peaks, and then they start to decline. Their stories are totally intertwined.
Okay, you're going to see notation like this sometimes. B, then 1930 in parentheses. I know, it looks like scary math homework, but trust me, it's not. It's actually just a really simple question wearing a disguise.
That's it. All B of 1930 is asking is, hey, what was Baltimore's population back in the year 1930? See, it's just shorthand. It's how we pinpoint one specific moment in the story of this graph.
So how do we find the answer? It's easy. You just find 1930 on that bottom axis, the horizontal one. Then trace your finger straight up till you hit the blue line. That's Baltimore. From there, just look straight across to the left to the vertical axis, and boom, it's right under 900,000. So we can say, yeah, about 880,000 people. Simple as that.
All right, your turn. Let's do a quick pop quiz. Find the year 2000 on the graph. At that exact moment, which line is higher? Is it Baltimore's blue line or Cleveland's red one? Take a look.
Yep, you got it. If you look at 2000, that blue line for Baltimore is sitting way higher than the red line for Cleveland. So in math speak, we'd say B of 2000 is greater than C of 2000. All that means is Baltimore had more people. See? You're already doing it. You're reading the story in the graph.
Okay, so we know there were times when Baltimore was bigger and other times when Cleveland was bigger. So does that mean they were ever, exactly the same? Is there a moment when their populations were tied? How would you even spot that on a graph?
Yes, absolutely. And this is a super important clue for us data detectives. The magic moment is when the lines cross. That intersection point, that is the exact moment when the 2 things are equal. And if you look at our graph, you can see it happen twice, once around 1920 and then again around 1945. At those 2 points in history, these cities had the exact same population. Pretty cool, huh?
Okay, detective, you are officially trained. You know how to pinpoint a value, you know how to compare which one's higher, and you know how to find the exact spot where they're equal. You've got the tools. So, it's time to go back to our TV shows and solve this thing once and for all.
So here are the official case files. We've got 4 descriptions, but wait a minute, we only have 3 graphs. That means one of these is a trick. It's a red herring. It doesn't belong to any of our graphs. Our job is to figure out which 3 stories match our 3 mystery shows. Let's knock out the obvious ones first. Take a look at show A. That line is just climbing and climbing, right? It's a story of pure growth. That has to be description B, the popular show whose audience just keeps getting bigger. Easy. Now look at show B. It's the complete opposite story. It starts way up at the top and then just clunk, nosedives. That is a perfect match for description D, the show that started huge and then totally crashed. And that leaves us with the most dramatic looking graph, show C. It's kind of flat, kind of boring, and then bam! Episode 5 happens. Look at that massive spike. The ratings more than double for 1 week and then drop right back down. That is a dead giveaway. It's the signature of a big guest star appearance, which is exactly what description A says.
So, case closed on those 3. But what about that leftover description, the red herring? Description C, a show with a small audience, but it's getting better. People are starting to notice. What would a graph of that story even look like? Just picture it for a second. It would have to start pretty low, right? And then just A nice, slow, steady climb upwards. The little engine that could. A sleeper hit in the making.
And you solved it. Mystery complete. But look, this isn't just about TV shows, obviously. This skill, being able to read the story in a graph, applies to pretty much everything. So let's level up and take a look at a couple of real-world examples.
Okay, check this out. We've got a toy rocket, that's R, and a drone, that's D. The graph shows their flight paths over time. So my question for you is simple. At exactly the 2-second mark, which one is higher in the air?
Let's take a look. We find 2 seconds on the bottom, we trace up, and what do we see? The drone D is just kind of hovering there at a steady 20 feet. But the rocket? Whoosh! It's all the way up at its peak, about 45 feet high. So at that moment, R of 2 is way, way bigger than D of 2. The rocket is definitely higher.
All right, last one. And this one has some real-world money on the line. Let's say you're picking a savings plan. Plan A is what you see on the graph. It's a nice, steady, predictable, straight line. Then you have Plan B. We can't see it, but we have a formula for it. And this formula means it grows faster and faster over time. It accelerates. So the big question is, after 1 year, that's 52 weeks, which plan leaves you with more cash?
So whose story has a happier ending? Well, if we look at the graph, after 52 weeks, the steady as she goes Plan A gets you about $110. Not bad. But when we run the numbers for Plan B, that accelerating plan, it's worth over $135. It tells a really powerful story about growth, doesn't it? The plan that started out slower actually ended up winning the race by a long shot because its growth was accelerating.
So you see, from the history of cities, to TV shows, to your own bank account, graphs are so much more than just data points. They are stories. They show us growth, they show us decline, they show us competition, and they show us crazy plot twists. So the real question I have for you is, now that you can speak the language, what stories are you going to find hidden in the data all around you?